So let's continue exploring the 2 momentum vector, which has components m over 1 minus v squared square root and mv over 1 minus v squared square root, where we remember when we evaluated this generalized dot product in space-time, we got m squared. So let's maybe go through that. Then we want to motivate this object as an energy momentum 2 vector. We already saw that we motivated this term as an energy. But let's first go back to this calculation. So we have PA, which we remember involved this thing called a metric, and so we need an object like this one that's slightly different from this one, which then allows us to do the sum. So this looks like a P0, P0 plus a P1, P1, and we want this object to then be the thing that turns the sign here, switches the sign. So, but this object is a little bit different from this one, which is this, which has no minus signs. So this is obtained from, so PAPA looks like, in terms of this kind of object, it looks like we need to apply this metric on one of these objects like these to lower the index, right? So we want to do that by having a PC index lowered to make this object a PA, and then we can do PAPA, and so it looks like that. And this becomes, so we're going to sum on A, and then we'll sum on C. So we have G 0, C is left as it is, P0, and then now A becomes 1, so plus G1C, PC1. And now we sum on C, so this becomes G, C is 0, so G 0, 0, P 0, P 0, and now C is 1 plus G 0, 1, P 1, P 0. So we've evaluated this out. We just summed over C, and now we're going to do the same thing here, plus G1, C is initially 0, P 0, 1, plus G1, now C is 1, P 1, 1. And of course, we remember that this object, the metric, is 1, 0, 0, 1. You can write it like that. And therefore, it has no cross terms. So all we have here are the G0, 0 and G1, 1 terms. So we have P0, P0, or P squared. That's 0, plus G1, 1. Oops, what did I do here? G1, 0. I made a mess here of these 2 terms. Let's write these again. So I have a G1, 0, C is 0, so this is P, there are 2 P's here. So it's P, C, P1, so this is plus G 1, oops, sorry, G1, 0, P0, P1, plus G 1, 1, P1, P1. And so these two go away, and we have G11 times P1 squared, which of course G11 is minus 1, so we have P0 squared minus P1 squared, and that quantity is m squared. Because, well, maybe let's continue working it out in terms of these components. Right, that's m squared over 1 minus v squared, p naught squared, minus p1 squared, which is m squared v squared over 1 minus v squared, which is in fact just m squared. So we argued, or we motivated the idea that this term here is the energy. So P naught is an energy. And so we are basically saying that this PA object, this PA2 vector, is really an object that has energy momentum in it. If we had the speed of light not equal to 1, this would be E divided by C, because dimensionally energy and momentum are obviously not the same. So there's a factor of speed there between them. And so basically what this is saying is that in space-time, right, these components, this is E squared minus P squared is equal to m squared, and therefore the energy in relativity is m squared plus p squared square root. And if we had the c not equal to 1, there would be a c to the 4th here, and there would be a c squared here.